Hello everyone. So today we're looking at matrices multiplication, right? Now we have already looked at addition and subtraction of matrices. We have also looked at scalar multiplication. Now we need to know what to do when multiplying a matrix by another matrix. However, before I go into the matrices or matrix multiplication, I am going to just review the basic concept of matrices. Alright, so to name a few, remember that a matrix is named by the number of rows and the number of columns. So for example, this matrix, if I have, it has 2 rows. Remember that rows go across. So that's row 1 and this is row 2. So row 1 consists of A and B. Row 2 consists of C and D. And then this has 2 columns. Columns are vertical. So column 1 consists of AC, while column 2 consists of BD. So this matrix has 2 rows and 2 columns, so it would be called a 2 by 2 matrix, right? Now if the matrix looked like this, then now we have 1, 2, 3, 4 rows and 1, 2, 3 columns. So it would be a 4 by 3 matrix. Each item in the matrix is an element, right? Alright. Alright, do you need to know anything else? No. And remember that for scalar multiplication, so that is when you're multiplying a matrix by a scalar. The scalar is just a number. So if I'm asking you to find 2A and the matrix A is 1, 2, 3, 5, 7, 9, then 2A would mean that you're multiplying each element in A by 2. So 2A would be 2 times the matrix, and I'm just being extra by writing this out, and that would be 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 5, 10, 2 times 7, 14, 2 times 9, 18. So each element, if we're multiplying by a scalar, each element in that matrix is multiplied by that number, by that scalar. Alright, good. So that's easy. Yeah. So if you need revision on how to add matrix, which is just adding corresponding elements, so first to first, second to second, and so on, you can revisit the addition and subtraction video that should be there somewhere. Alright. So now we're looking at multiplying 2 matrices or 2 matrices. Now in order for 2 matrices or 2 matrices to qualify for multiplication, meaning qualify for them being able to be multiplied together, the number of columns in the first matrix must be the same as the number of rows in the second matrix. So this is a 2 by 2. This is a 2 by 2. This and this must be the same for you to be able to multiply the 2 matrix. Now these 2 matrices have the same order, right? Both of them are 2 by 2. So there is no question that they can be multiplied, right? Because it's 2 and 2. So first column in first matrix is the same as the number of rows in the second matrix. So they can be multiplied. I will look at another where they are not of the same order, but they can or cannot be multiplied. So we are going to go ahead and multiply these 2 matrices. Now, the rule for multiplying matrix is row by column. When you multiply in matrix, you multiply row by column. What I normally do is draw a line to show my row in the first column, my rows, and draw second column in the second matrix. So I draw a line to show my rows in the first matrix, and I draw a line to show my column in the second matrix because it's row by column. So what we're gonna do is multiply. Alright, so when we're multiplying, it's first row by first column. And that gives us the first element. Alright? So it's gonna be 3 first element in first row times first element in first column. So that's gonna be 3 multiplied by 1 plus second element times second element. So 5 times 2. And this gives us the first element when we simplify it. Then we're going to go over to the next side. We're still in the first row. We're building the first row. You're going to use again the same first row, but this time you're going to multiply it by the second column. So it's going to be 3 multiplied by 7 plus 5 multiplied by 8. First row is complete. Then for the second row, we go to the second row. And we start over the process of multiplying, but this time we're multiplying by the second row. So it's going to be the second row again. Well, not again, because we're just using it. The second row times the first column. Then you're going to use the second row again by the second column. So it's going to be 4 multiplied by 1 plus 6 multiplied by 2. So notice here you have times 1 times 1 times 2 times 2. So if your n numbers are not lining up, that means something is out of place. Alright? Then we go to the second column. So we're multiplying using the first row again. 4 times 7 plus 6 times 8. So notice 1, 1, 2, 2, 7, 7, 8, 8. So the n numbers in the same column are the same. And then you can say that the first digit in the rows are the same. So 3 is here, 3 is there, 5 is here, 5 is there, 4 is here, 4 is here, 6 is there, 6 is there. Hope you're seeing it. And don't worry if you don't get it the first time, you can watch the video again and slow it down and pause, right? And then now you can proceed to simplify. So the fact that we're multiplying a 2 by 2 matrix by another 2 by 2 matrix, your result should be a 2 by 2 matrix. So we're going to get 3 times 1, 3, plus 5 times 2, 10. On this side, we're going to have 3 times 7, 21, plus 5 times 8, 40. Down here, it's going to be 4 plus 12. Over here, 28 plus 48. I didn't have to put this line, but it's just for clarity. Alright, I could have, after this, I could have just gone to the answer. Alright, so the final answer is 13, 21 plus 40, 61, 4 plus 12, 16, 28 plus 48, looks like 76, And that's our answer. So again, we have a 2 by 2 matrix. So multiply the row by column. Same row again by the next column. Then we go to the next row, column. That same row by the next column. Alright, that's it.